So in the last video, we talked about 5.68 part A. Now we look at part B using the table to find the solution. So just pay attention to the problem, because this time we're looking for at most 3 RH negative. So the probability of RH positive RH negative is 0.15. So when we look at the table, we got to look at this column, 0.15, and at most 3, and that would be this row right here. So we found out this is the number for p equal to 0.15, and little x is at most 3. So 0.9786. Of course, you can still use the old way, the definition, to do the problem instead of using the table. So like what we did here in the solution, at most 3, which means maybe 0 RH negative, or 1, exactly 1 RH negative, or exactly 2 people are RH negative, or exactly 3 people are RH negative. So we can use the formula, this formula for exactly equal to find out F0, F1, F2, F3. So plug into the formula 8 and choose 0. And again, one more time, a correction here. 8 choose 0 should be 1 right here, not 0. Any number choose 0, there's only one. It means you don't choose anybody, there's only one way. So this should be 1 here, not 0. And 0.15 raised to 0 again is also 1. Any number raised to 0 is 1. Times 0.85 raised to 8th power, because m minus x, 8 minus 0 is 8. So you can use the calculator to find out it's equal to 0.2725. And then we can use the formula to find out f of 1. So 8 choose 1, and p raised to 1, and 0.85 raised to 8 minus 1, which is 7. So we get this answer, and find out 8 choose 2, and 8 choose 3, plug in the formula. So we find out all these 4 different values, and we need to add them up. Add up 0 person, 1 person, 2 people, 3 people, and altogether that would be called at most 3 people are RH negative. So this is the probability. We have 97.92% of the chance that at most 3 are RH negative. Okay, so you can see it's very high. And now let's look at a 5.70. So this one we will use the table to do it. You can also do what like Stephanie did before, like this way. X is at most 1, so you can use the formula. You're doing 0 and 1, so adding 0 and 1, p equals 0.10 and n equals 12. So plug into this formula one more time to get these two and add them up. But of course, using table is much easier. So what we do is, how do we use the table? N equals 12. So let's go to the table and find n equal to 12. It's right here. And then the probability p equals 0.1. So I go to the table, find the 0.1. It's right here, this column. And then we at most 1, so we find at most 1 right here. So this is the number 0.6974. Wait, 6. It's point. I'm sorry. N equals 12 should be n is equal to 12. So I should go under n equal to 12 at most 1, and it should be this number here. 0.6590. So n equals 12, and p equals 0.1, and at most 1, 0.6590. So it's okay, 0.6590. And the next one, x is at most 2. You cannot use the table directly because this table is only for at most. So we have to change it. At most, at least 2 means at most it's everybody, the probability 1 minus at most 1. Okay. So at least 2 means you have to have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you definitely don't want to use this way to do the problem. You try to use this formula, then you have to do it like 10 times, and that's too much work. So it's easier to use the table. And how do we use the table? We can, if it's greater than or equal to, we cannot use the table directly. So what we do is we change it to the probability 1 minus exclude the probability of at most 1. Okay, so we from part A we know at most 1 is 0.659, so 1 minus 0.659 we get a 0.341. And this number here, 0.659, is from the table. And part C, we have a formula to find out the expected value, or you can call it population mean. So the formula given in the book is population mean, a new formula for binomial distribution, equals n times p. So n is 12, p is 0.1, so it's 1.2. And where does this formula come from? It has been proved, so you can use the formula directly. And so now we have, for mean, we have 3 different formulas. One is for sample mean, we add all the values and divide by to the size. And for the population mean, one formula we did before is like this. We multiply x value and its corresponding probability and adding up to get a population mean. And actually, this formula, this is the third formula only for binomial distribution. You can use n times p, and you will find out you will get the same answer. So this way, or using table, you should get the same answer. Okay, so now let's look at the next example, question 5, last question 5.74. So in this question, part A, we want to make a list of we know it's a binomial distribution, n equals 3, p equals 0.6. So for the x values, x is how many successes. So if you do a trial, some kind of experiment 3 times, and how many successes will you have? All the possibilities. So you may have 0 success, you may have 1 success, 2 successes, or 3 successes. And for each one, you will find out its corresponding probability. So you will have to use that formula again we had before. Again, one more time. It's this formula here. So binomial distribution, this is the formula for binomial distribution. We have to use it again and again. And so here we plug into the formula n equals 3, so 3 choose 0. And p equals 0.6, and 1 minus p is 0.4. So we plug it in, we get the answer. And for n equal to 1, we do it again. N equal to 2, use the formula again. N equals 3, use the formula. So we got those numbers here. And that's part A. So part B, we want to find out population mean and the standard deviation. And so we use the table right here. And we have just found out well, this table right here we just found out, so we can multiply, like in last homework we talked about, we can the formula we have is for population mean, we multiply x value and its corresponding probability and adding up. So we 0 times 0.064, 1 times 0.288, 2 times 0.432, and 3 times 0.216. We get this column, and add all these values, we get 1.8. Okay, and you can verify this way with the formula. The formula given is n times p. which is 3 times 0.6, we get 1.8, exactly the same thing. And so this formula has been proved, so we don't have to do this way anymore for only, but of course this formula only works for binomial distribution. If it's not a binomial distribution, then you still have to do this way. And then we try to find a variance by using the formula. We have to do x minus mu, so x for each x value minus the mu population mean, and then square all these values, we get this, and then multiply this column by its corresponding probability. So we get these numbers and adding up, so we get a 0.72, and that is the variance. And take the square root of the variance, we get the standard deviation. And the formula given in the book is for binomial distribution. How do we find the standard deviation? It's square root of npq. So n is 3, p is 0.6, q is 1 minus p, that's 0.4. And so which is exactly 0.72, that's the variance, and take square root, we get a 0.8485. So for binomial distribution, we have very quick way to find population mean and population standard deviation, NP and square root of NPQ, instead of doing the old way from last chapter, chapter 5. But remember, these formula only work for binomial distribution. If it's not binomial distribution, we still have to do the old way, this formula here. Okay,